So first thing you're going to want to have out is this unit circle paper. On the front, it's going to be the major unit circle, and on the back, we're going to start talking about the families of unit circles. So I'll let you get that out. Next thing you're going to need is you're going to need 4 different colors. I would recommend using the following: a yellow, a green, an orange, and a blue. So go get them. Pause me. Oh my gosh, okay, here we go. So first thing we're going to start with is this one. What we're getting into today is looking at each individual families of the unit circle, because all together they combine to make one gigantic unit circle at the end. So we're going to start over here. We're going to use yellow. So we're going to start by highlighting our axes. And the reason that we're highlighting them in a specific color is because we're going to change these to the front sheet of the paper, and we're going to have all the colors in one. So here we go. So yesterday we talked about a little bit about with radians and degrees and converting them back and forth. So obviously we know that 0 degrees starts here, and then if we go halfway around the circle, we get 180 degrees. If we go halfway around the circle again, it completes our revolution, and we get 360 degrees. So hopefully you should be comfortable with that. Now let's think about it this way. If halfway around the circle is 180, if I take half of that, I have how many degrees?
90.
90! And if we keep going likewise this way, halfway between 180 and 360 degrees is?
270 degrees.
270 degrees. So this family is called our 90-degree family. 90-degree family. So we have this in degrees. We also can go back and then put them into radians. So let's think about it radian style. Yesterday, we said 0 degrees is the same thing as 0 radians. If we go halfway around the circle, it's pi radians. If we come back around, it's 2 pi radians. So let's think about it. If I want to take a half of pi, it's going to be pi halves. Then, if I want to get 270 degrees, I want to take a half of pi and 2 pi. So the number smack in the middle between is?
1.5.
1.5, and we can write that as an improper fraction. So 3 pi over 2. This is our 90-degree family. Notice there are 4 of them. All right, let's go to our next one. Over here. If you notice, we have double the amount here. Let's use our blue markers. So again, start by highlighting these. Pretend those are on the lines. And again, let's start with our basics. We know 0 degrees is over here. We know 180 degrees is over here. We just learned in this one that 90 is on top and 270 is on the bottom. So now we got to figure out what are these missing pieces here. Well, if you look, this is exactly halfway between 0 and 90. And exactly halfway between 0 and 90 is?
45.
45 degrees. So now we're going to go to this one. I'm between 90 and 180. And exactly halfway between 180, or 90 and 180, is 135. In other words, every time you get to the next one, you're going by 45 degrees. So you should be able to finish this out. I'll give you a few seconds to try to figure that out. Pause me, and then you can come back and let's check it. So hopefully you paused me and you got a chance to actually fill them in. So this should be 225 degrees, and then this one should be 315. And then obviously we're back at 360 degrees. So just like we did with the 90-degree fam, if you haven't guessed it yet, this is the 45-degree fam. We can go into radian mode. So let's think about this. If we're pi halves to get to 90, we want to do half of pi halves. So what that means is we're chopping this in 2. Or we can multiply by 1/2, same thing. So you should be able to realize that this is pi over 4. So all of these are going to be in terms of pi over 4. And the way you do this is obviously you can use the conversion formula that we used yesterday, 180 degrees over d equals pi radians over r, or you could count them. So this is 1 pi over 4, this is 2 pi over 4. Well, 2 pi over 4 simplified is pi halves. So 1 pi over 4, 2 pi over 4, then 3 pi over 4, then 4 pi over 4, but 4 pi over 4 is pi, then 5 pi over 4, 6 pi over 4, but 6 pi over 4 we said was 3 pi halves, 7 pi over 4, and 8 pi over 4, which is 2 pi. So if you need to take a second, gather your surroundings. So far we've done the 90-degree family and the 45-degree family. Now we're going to move on to 2 more families after I erase. Alright, so next one we're going to do, let's grab our green marker, and we're going to come over here. So again, start by highlighting those great lines. We're going to use green. I think I already said that, but I'll say it again. And of course, we have 0 degrees, 180 degrees, and 360. So in this one here, we talked about a 45 family, a 90 family. Now here we have our 60 degrees family. So obviously, if we start at 0 and we want to go up, this is going to be 60 degrees. Then I'm going to add another 60 degrees. That gives me 120. I'm going to add another 60 degrees. That gives me 180. Add another 60 degrees. That gives me 240. Add another 60 degrees. We're at
300.
300. And finally, we make our way back to 360. So again, now let's think about it in terms of radians. So you can either use your conversion formula, or once you figure out that 60 degrees in radians is pi over 3, you can figure out the rest of them. Because remember, you just count up by 1. So we have 1 pi over 3, now we have 2 pi over 3, then we get to 3 pi over 3, which is just pi, then 4 pi over 3, 5 pi over 3, and 6 pi over 3, which is 2 pi. So that's our 60 degree family. All right, our last one is the orange family. So go ahead and trace over an orange. Now if you notice here, these two are related as well. This is our 60 degree angle, and we're actually going exactly half of 60 degrees. So can you guess what this family is called?
The 30-degree fam.
The 30-degree fam. So here you go. 0, 30 degrees, and that's your task. Keep adding around 30 degrees until you get all the way to 360. So check back in with me in a minute. All right, you should be tuned back in. So at this point, we now have all of our degrees, each going by 30. So now we got to figure out, okay, what is it in radians? So if you haven't done it yet, we're going to take the time to actually do this one using the conversion formula, so hopefully it makes a little bit more sense. So we said that 180 degrees over d equals pi radians over r. Don't worry, that wasn't your bell, you're still here. So obviously if we have 30 degrees, that's a degree, so that goes in here. And we're going to cross multiply. So now I have 30 times pi radians. So 30 times pi radians. And that equals 180 degrees times r. So now I got to get r by itself. So I'm dividing both sides by 180 degrees. Obviously the degree symbols are now going to cancel out. And now we have to simplify 30 over 180. Which is?
6.
Alright, we're simplifying 30 over 180, so that's going to be pi 6 radians. Alright, so that tells us that here, we're going to go by pi over 6. So now, we're going to keep adding every pi over 6. So 1 pi over 6, 2 pi over 6, but 2 pi over 6 is pi over 3. 3 pi over 6, which is pi halves. 4 pi over 6, which is 2 pi over 3. 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. 8 pi over 6, which is 4 pi over 3. 9 pi over 6, so 3 pi halves. 10 pi over 6, so 5 pi thirds. And 11 pi over 6, and then of course 2 pi. Woo! So we got all of our 30-degree angles in there, all in radians. So as you can see, we have our 90-degree family, 45-degree family, our 60-degree family, and our 30-degree family. So now that we put these all in color, we can go ahead and transfer them to the front of our sheet. So take some time to do that. Obviously, I would not rush to color all of them because you might get a little bit mixed up. You might have realized that when you look here, some of them actually overlap. So for example, 60 degrees overlaps here, and so does 120. So when you transfer it to the front, be careful when you go and shade them in. So I will give you a finished copy of it that you can look at to make sure that you have the colors correct. Obviously, if you use your own colors, you're going to be on your own. Alright, so now you should be pulling out your notes packet, and then what I have up here is I have the unit circle, the front page of that, on reference, so this will help us fill it out. Obviously, if you get the opportunity, you might want to copy down these angles into your notes packet, just as you're flipping through your notes packet, so you have it as another point of reference. And honestly, the more times you write down the unit circle, the easier it's going to come to you. Obviously, we're not requiring you to memorize every single piece on the unit circle, but it's important that you're familiar with where they go. And that'll help us answer these questions here. So, we're coming up here. So if this is our unit circle here, we think about this as an XY plane. Hopefully we all remember what an XY plane is. If we're graphing, we have a few quadrants. First, second, third, and fourth. So here we go. If we're in quadrant 1, what are our angle measures? Obviously, this is quadrant 1 over here. So that means we go from 0 degrees until 90 degrees. If we're thinking about that in terms of radians, that's 0 radians until pi half radians. Now we get to quadrant 2. So quadrant 2, I'm starting at 90 degrees, and I go till 180 degrees. In radians, that's pi halves, all the way to pi radians. Q3, hopefully you're starting to catch the drift. 180 to 270 degrees. So that's pi to 3 pi halves. And then last but not least, we have 270 to 360 degrees. In other words, 3 pi halves to 2 pi. So those are our quadrant separators right there. So now we're going to get into stuff with directed line. Actually, before we get into directed line, so let's take a second now that you have everything formalized on your paper, and let's look at these questions. So which family of angles is the quadrant separator? So obviously we have 4 quadrants. So which family of angles separates us into 4 quadrants?
The 90 fam.
The 90 fam. What family of angles is exactly halfway between these quadrants? So half, 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 and half.
The 45 degree fam.
45 degree fam. Which family is closest to the y-axis? So if we're looking here, which one is highlighted? You see that's the green ones highlighted, which are the
60 degree fam.
60 degree fam. And then obviously closest to the x-axis, those are the orange ones, so those are the
30 degree fam.
30 degree fam. So those are important to know. And the reason we want to know these is exactly for the next thing that we're about to do. So again, keep in your mind, 90 degrees, those are exactly the quadrant separators. 45, exactly halfway. 30 degrees is closest to our x-axis, and 60 degrees is closest to our y-axis. So this will help us do what is next. Alright, so we have what's called directed length when we have angles in our standard position. So obviously, I don't think I've said this before, but every single time we've been putting our angles in this direction. We've never gone in this direction. Do you think that makes a difference?
Yes.
It sure does. So, think about it this way. Anytime we have a positive angle, we are going to start at our 0 degrees and work our way counterclockwise. So a positive angle, anytime we have it, it's going to go counterclockwise. That's what CC stands for. Another way you can think about that is you go up. So, if we have a negative angle, that means we still start here, but now we go down, or we go clockwise. So this is going to help us when we have to draw an angle. We're not going to be breaking out our protractors because we're just going to estimate where those angles are. So that's why knowing which family is closest to the x-axis and the y-axis is going to be very helpful. So let's go ahead and get out that worksheet that we gave you. It's all on directed line. And we'll do a few together, and then you'll try some on your own. So obviously, let's start with an easy one. Let's start with a positive angle. If I have 60 degrees, we start at 0. And 60 degrees we said is closest to which axis?
The y-axis.
All right, so when we go and draw our angle, obviously we have here, but then it's going to be closer to the y-axis here. Okay, so now this whole point of directed length in standard position is we have to put an indication for which way our angle is going. So we said this is positive, which means from this axis we go up. So all we're going to do is draw an angle right there. That represents that we went positively in this direction. Let's try a negative one. So let's go over here. So I want to go negative 120 degrees from my starting point. So we just said that negative means you go down. So that means I have to go down 120 degrees. Now obviously, you're probably wondering, where does that wind us? Up. Well, obviously if we go 90 degrees, we're at this axis here. So I'm going to have to go how many degrees more past this axis?
30 degrees.
30 degrees at this. So now we're here. Okay, so we started here and we came down closest to the y-axis. So we're going to draw an arrow like that. So what I want you to do is start going through the rest of them, start in degrees, and then eventually you're going to turn to the back and do the same thing in radians. I know radians is a little bit of a new concept for us, but we've got to start thinking about angles that can be radians as well, not just degrees. So if you want, I will scroll up to one that is in radians, just so we can see what that means. So if we're looking here at 3 pi halves radians, so 3 pi halves means it's the 90 degree family, and because this is 3 pi halves, that means we went 0, 1, 2, 3. So we're actually at this y-axis down here, that's 270 degrees. And because I'm positive, I'm starting here, and I'm going counterclockwise or up. So I'm going to draw it like that. So there you go. Please go ahead and finish the rest of the worksheet and be ready to go for tomorrow.